if you could introduce yourself before ask a question, tell us your name and what brings you here. We much appreciate that, and then we'll launch straight into this. Please. Or I'll pick up you, not you.
I'm Charlie Adler. I've sort of been a community activist in my hometown Adler on this issue. I wonder if there's a way to quantify more of the possible human impact. It almost seemed like we had more statistics on other species impacts than we can muster for human impact. And that's, I think, what would really move the decision makers. Thank you.
So some of the, I think that's a fair, we do have better, people seem to be able to quantify more specifically with respect to other species than with respect, or willing to do it maybe. Which is maybe perhaps surprising because there was an article in the journal Science recently that said essentially that we don't even know 2/3 of the species in the ocean. So it's a little bit tough to know exactly how many are going to be lost. But the projections, for example, on climate refugees, they're quite wide. And it's hard to disambiguate sometimes political refugees from environmental refugees and other sorts of things because there's multiple forces going on, right? There could be ecological problems that are leading to violent conflict that then lead to things. So people are trying to guess they're trying to sort out what's the contribution of the environmental factors and the climate factors to, say, creating refugees, and then project this forward based on sea level rise. So you get really wide ranges. But most of the estimates, for example, on refugees now are that it's possibly hundreds of millions of refugees, hundreds of million people who are displaced. I mean, I think that's pretty powerful. And then the other thing is then the actual current events, right? So you can, there's the U.S. Temperatures of last year, but there's also wildfires raging in Australia right now, right? Because of historic droughts and levels. So yeah, there's not great numbers, but the numbers that are out there, I think, are still, I think they can be pretty powerful. The refugee numbers, especially, I think people find compelling.
Another question, okay.
Well, my name is Alex Marstein, concerned citizen. In fact, I wanted to ask about refugees in particular. You had a 2005 figure there for 20 million climate refugees, I believe it was called, or ecological. Could you talk a little more about that and comment where they are, how exactly their climate and not mixed with another type of refugee?
Yeah, so again, it's difficult to disambiguate. So that was environmental refugees. So these are people who have been counted as displaced due to not political conflict and not forcibly to leave, right? But have left because the ecological conditions under which they live are no longer seem sustainable, right? So they have to move. So those can be, again, things like sea level rise, agricultural insecurities, droughts will cause people to move. The report that's from is from the United Nations Institute called the Institute for Environment and Human Security. And so if you go to there, you'll be able to find that, and they'll break it out for you how they do the calculations. So there's a reference.
I'm Dan Grossman. I'm a science journalist. I don't think either of you is a fortune teller, so I'm not sure how you'll be able to answer this question, but I'm hoping you have some thoughts. It seems like you're giving us very pessimistic scenarios for the future, and yet I wonder if even if you still might be pulling your punches. And the reason I wonder that is if there were, let's say, a 50% species loss, which I assume is just some sort of extrapolation, what would happen to the rest? What would happen to the ecosystems that those species lived in. I presume that when you get to 50%, the whole thing might, the ecosystem might collapse, and it might be, virtually nothing would remain. Same thing with human impacts. If you're talking about hundreds of millions of people displaced, it's not just like hundreds of millions of people, individuals would go do something else. There would, I presume, there would be some sort of chaos in various parts of the world that would disrupt global commerce, that might have big impacts on oil shipments. It might have impacts on our ability for let's say, for our society to continue to function the way it does.
Well, that turns out to be a question that the Defense Department and the Intelligence Department in the United States is becoming extremely concerned about and interested in. And the way in which it's quantified turns out to be, as you can guess, extremely difficult. As mentioned in here, Australia is going through multiple droughts. The core of the United States had a very serious drought this year, but it's a developing pattern. It's actually quite simple. When you add more and more, more and more carbon dioxide to the atmosphere, it shifts the jet stream north, so it moves the climate of Mexico into the central part of the United States, northern Africa into the Mediterranean, Western European sector, same thing in Asia. So the way in which the forecasts, as you mentioned, are difficult, but the conclusions are more and more serious for all aspects of civic stability. And we didn't get a chance to talk about a number of these. And if I stand back and look at this from the perspective of all of these considerations, it's very clear that when we're above just 350 parts per million, all of those glacial systems, all the cryogenic systems in the northern hemisphere are essentially unstable. And so this means that we have two choices. In the immediate future, we can block incoming solar radiation in order to decrease the heat flow in the systems that I was talking about. But that's only a very minor fix, because ocean acidification that wipes out species in the ocean continues to build proportionally with the carbon dioxide pressure in the atmosphere. And so I've come to the conclusion, because of this very long lifetime of carbon dioxide in the atmosphere, we're simply going to have to extract it. And the current running price on that is $200 a ton of carbon. Now, Ronnie's using tons of carbon dioxide, I use tons of carbon. The conversion factor is 12/44 to adjust for the mass of the two. So this is in tons of carbon I'm talking about, $200 a ton to extract it. And I, frankly, because of the instability of the system over 300 parts per million of carbon dioxide, I look at these curves, and they are catastrophic when you start to calculate these feedbacks. So we simply have to withdraw carbon dioxide from the atmosphere. There's no other solution. And we talk about a carbon tax. People are talking about $20 a ton. Well, this is just pathetic. So I've come to the conclusion, and this is not impossible. I know what I say can bring various states of depression, but there's a very clear way out. And by the way, I don't think this is going to be a matter of the quality of life. I mean, you mentioned that if we were tied inextricably to carbon-based fuel, that would be true. But The United States is endowed with renewable energy to a profoundly important degree. 15% of the area of the Middle West would generate a third of our total primary energy from wind power. 8% of the area of Arizona would give us another third from concentrated solar thermal. And energy storage and energy intermittency has been discussed as a serious drawback. It's not. There are energy storage methods that can smooth out the balance between demand and production. So both the United States and China are unbelievably fortunate in our ability to generate primary energy without using fossil fuels at all. And I have to say that, you know, we spend $1 trillion a year on the military, and we spend another $400 billion a year buying petroleum overseas. Both of those have to be inspected very, very carefully. The rest of the world spends $500 billion. The entire rest of the world spends $500 billion on the military. We spend twice as much as a combination of every other nation on earth on the military. And this is not a long-term strategy for security, because security evolves from a strong economic base. And you can just calculate, it costs $1.50 a watt to install wind power. That's 1.5 trillion for a third of our total energy requirements. And concentrated solar thermal is a little over $2 a watt. 5 years of reasonable reapportionment of how we invest our resources gets us on an entirely new track. So this isn't going to compromise standard of living. Our standard of living is going to be massively better under these circumstances than it is now. But the real issue is we're at 400 parts per million of carbon dioxide, 480 effective when you put in methane and N2O and so on. We have to extract that back out.
Can we hear on the far left side?
Considering the melting of ice on Greenland.
Hi, I'm Charlie. Considering the melting of ice on Greenland, is there any thought on the conservation of this freshwater source, say in a large-scale reservoir, as a possible way to limit sea level rise? You know, this ice.
Well, if you calculate the area of the Earth and then take a depth of 3 meters, I think that's the answer for you. That only 30% of the Earth's surface is land, and so that's a very reasonable question to ask. Numbers are just staggering.
The lady in the last row here, in the front section.
My name is Catherine Tumber. I wonder if you, Professor Anderson, could say a little more about the methods for extracting carbon from the atmosphere. I haven't even heard of that concept. Maybe the rest of you have, but I'm not familiar with this idea. Sequestration? I don't know.
Well, yes. I mean, carbon capture and sequestration would be a very important part of this. It can be buried so deep in the earth that it will be irreversibly extracted from the atmosphere. So that's possible. Now the ocean, of course, over time does a beautiful job of this. The biological machine in the ocean constructs calcium carbonate skeletons that sink to the bottom, and that's what all the beautiful sandstone is that we have. So nature is very good at this. The problem is that the rate at which it occurs is on the time scale of millions of years. In fact, 40 million years ago, we had 900 parts per million of carbon dioxide in the atmosphere. And nature, through the carbonate silicate reactions, extracted all of that and buried it at the bottom of the ocean. Now we can speed that up with biological systems. We can also extract carbon dioxide from the high carbon or high CO2 content exhaust from power plants and sequester that. When you extract currently existing carbon dioxide from the atmosphere, it becomes much more energy intensive because it's far more dilute. But we have to go after that component. And there are techniques now being developed to do just that. And then you either take that extracted CO2 and bury it, or you form a mineral and sink it in the ocean. So there is a huge amount of research going on now to do just that. And there are startup companies beginning. And that's in fact where I got the price for the extraction, $200 to $300 a ton. So it's possible, and that's why I'm not terribly pessimistic, but we have to completely change our perspective on this. It's very exciting, actually. I mean, I wish I were a 20-year-old now, because there's never been a more exciting link between energy technology and social responsibility than there is now. Who else wants to be 20 years old? That was a pretty stupid thing to say, but
My name is William, I'm a PhD student here at Northeastern. You mentioned that there were energy storage options that are available now that can solve the intermittency issue. I'm wondering which technologies in particular you feel are ready to deploy right now, other than hydro pumping.
oh, okay. That would have been about the fifth on my list. It's a very important one, as you probably know. So I started doing these calculations because I thought that wind and concentrated solar thermal would have a huge and unsolvable issue. Now, if you look at the breadth of the United States and you install both wind and solar thermal judiciously placed, it turns out that those two largely balance one another, because when you have a high pressure area coming through, you have beautiful weather, sunlight, so concentrated solar thermal is operating at maximum efficiency, but high pressure brings low wind speed, so you lose significant yield from the wind system. A low pressure area comes through, wind power takes over. So if you connect all of this, which is crucial for the national grid, I mean, we've got to lay high voltage DC power lines along all the interstates. The government owns the property, we just sink that grid in. And by the way, the capital investment in the grid is about 10% of the installed cost of wind. Okay, so now to the intermittency problem. Wind, the most remarkable one, which when I did the calculation, I couldn't even believe the numbers, and that's thermal storage. So in your backyard, you've got a volume about 3 meters by 3 meters of ceramic brick. So anytime you have excess power generation and you're in the winter, you just heat that, and then you extract the heat to heat your house. Same in the summer, you just cool it, and those numbers are really remarkable, how you can store thermal energy and use it. The next one that's important is pressurizing caves. In fact, the Middle West has many of these right at the same site that the wind is being generated. So if you're overproducing electricity from wind power, you simply compress that air into these large caves, and then when you need the power back, you extract it. As we move more and more into the electric car industry, when you plug your car in at night in your garage, your meter knows from the subtle fluctuations in the voltage on the line whether there's overproduction or underproduction. So you buy electricity at 8 cents a kilowatt hour to charge your battery, and you sell it back at 13 cents when the power requirement is. So that turns out to be a non-insignificant part of stabilizing the balance between demand and production. So my conclusion after I worked this through, and the reason I did this is that I've been working 4 or 5 years now on freshman chemistry. Harvard, so we teach those principles now in this global context, while you're writing all these case studies in order to link the central concepts into the global issue. And I went through and I did all the numbers, and I'm convinced that these energy storage techniques are crucially important. Hydroelectric is another beautiful one, because you can spin up those turbines in 30 seconds. And as you point out, you can also pump water uphill to recapture it. So when you take the composite of all of this, intermittency is a non-problem.
One more question.
Oh, the question's worth the trip.
Hi, my name is Chris O'Keefe. I'm a student here of this class for a couple of years. In terms of riding your bike to work and reducing the amount of CO2 that we put in, seems to me from what Professor Anderson says, that's dwarfed by the permafrost and the ice.
Yes.
So in terms of what we think of as the top of mind conservation kinds of behaviors really almost aren't relevant. But from what you're talking about now, it sounds like, and what the policy direction that I can see this going in, is that a scientifically literate civic conversation is really what's going to be critically important, because there's so much misinformation around it. If, in fact, more people were able to understand what you're saying, it must bring the political will to do some of these things. Might not be nearly as difficult.
Well, I couldn't agree more. I mean, I've ruined every evening and weekend of my wife's life for the last 4 years working on exactly this point, and you're absolutely right. And the information is crucial, because let's take the energy demand to fly. I mean, if I add up all of my demand for energy, my own personal energy calculation, it doesn't matter what I do, I destroy it because I fly so much. But the capability of producing biofuels in this country is so large that aircraft use 6 to 7% of petroleum globally, but we can easily fly all the aircrafts that use internationally on biofuels. I mean, the Air Force has this huge program. They're flying all their B-52s on biofuel now. And so we don't have to stop flying. We just have to wean ourselves off of all of these other carbon-emitting fuels and use biofuels for aircraft. It's the only mode of transportation that actually requires a liquid fuel. So getting back to your point, the consumption of energy, and you use the bicycle analog, it's actually quite important that people don't commute in cars that are fueled by petroleum. That's the killer. I mean, that's a massive contribution that can be quite easily corrected. And cities are remarkably efficient because people are walking and riding bicycles. I mean, the consumption of energy per person in the city is a tiny fraction of what people who live in the suburb. And I live in Lexington, so I'm culpable. But I'm living in Cambridge in a year, so.
I can't tell you how pleased I am that we're concluding this evening on a positive note. Many thanks to our speakers, Jim Anderson and Ron Sandler. Many thanks also to all of you for your questions and for your participation. Before you leave, I'd like to alert you to the next week's speakers and topic. We'll then begin to grapple those complex issues of governance, what to do about the climate challenge and how to do it. And we'll be very fortunate to have Sonia Hamill, who some of you might know, a very active local policy maker and advisor who also has worked and advises governments not just here in Massachusetts, in New England, in the United States, but also worldwide, specifically in Europe. And Bill Moomer, who has been instrumental in the early days of the Montreal Protocol, banning CFCs and dealing with ozone depletion, and who in the last 2 decades has dedicated much of his energy and time and research on international climate negotiations and policy. So we'll have both of those here. Both of those will present both a local and a global perspective, and hopefully we can move on this trajectory of positivism here. Thank you so much to all of you.